frequency. And other is more than cumulative frequency. So let us see what is less than cumulative frequency and what is more than cumulative frequency. Suppose there is x1 to x2, x2 to x3, x3 to x4, and xn to xn plus 1. Okay, and this one is x1, this one is x2, this one is its frequency is f1, f2, f3, f4. So less than CF is this one, f1, f1 plus f2, f1 plus f2 plus f3, and it is fn, f1 plus f2 up to fn. Now more than CF can be defined as fn, fn minus 1 plus fn. Okay, and again this one is f1 plus f2 plus fn. So this is more than cumulative frequency. Okay, so if you plot a smooth line, okay, say along x-axis, if you plot the upper limit of class interval cumulative frequency against upper limit of class interval, and less than cumulative frequency, then CF okay, and lower limit of class interval, lower limit of class interval versus more than CF. Okay, so keep this thing in mind. Upper limit versus less than cumulative frequency. So it will be less than ogive. So you will get this one. Okay, so this is for plotting 1. And this is for plotting 2. This one is for plotting 2. Okay. So what you have to do, you have to simply plot the upper limit of class interval versus less than cumulative frequency. Similarly, lower limit of class interval versus more than cumulative frequency. And this one is what? One is less than ojai, and two is more than ojai. Okay, and this inter intersection of less than ojai and more than ojai is median. Okay, so this is basically the problem. This is basically the less than ogive and more than ogive, and it can be used to graphical location of partition values. Okay. Now I'm giving you a problem, and what you have to do, you have to plot less than ogive and more than ogive. So this is class interval and this is frequency, and you have to find out more than frequency and uh, more than ogive, then less than ogive. Okay, and this you have to calculate more than CF, less than CF, and then what you have to do, you have to plot less than ogive and more than ogive. Okay. Now we will discuss the measure of dispersion. Okay. Now we will discuss measure of dispersion. So meaning of dispersion is scatteredness. Scatteredness. And we study dispersion to have an idea about about homogeneity or heterogeneity of the distribution. Distribution. पेटीएम ओपन करो तो पेटीएम ओपन में पहला ऑप्शन तो पे का होगा पहले homogeneous. What is meaning of homogeneous? फिर पहला ऑप्शन क्या होगा homogeneous means less dispersed and heterogeneous is more. Okay, so this is the meaning of heterogeneity or homogeneity. There is a definition by L.R. Corner. Dispersion is a measure of extent to which individual item well. Okay, and this definition is given by L.R. Corner. Okay. Now, characteristics of ideal measure of dispersion.
सर एलआर कॉर्नर क्या सर?
हेलो हाँ
सर एलआर कॉर्नर क्या सर?
Wait for a minute. Actually, I think I'm not able to hear you. So let me connect my phone. Okay. Okay. So, what you want to say?
सर वो एलआर कॉर्नर क्या लिखे थे सर उसका मतलब?
एलआर कॉर्नर जो है उनका ये डिफिनीशन है, ठीक है। ये डिफिनीशन जो ऊपर मैंने लिखा है, दैट डिफिनीशन वाज गिवन बाय एलआर कॉर्नर।
ओके सर,
ठीक है।
यस सर।
ओके, देन कैरेक्टरिस्टिक्स। For an ideal measure of dispersion. So there are various characteristics. First is rigidly defined. Second is easy to understand and calculate. Third is based on all the observations. Based on all the observations. Okay. Is it okay? And fourth is usable for further mathematical treatment, and 5 is effective as little affected as little as possible by fluctuation fluctuations of sampling. Okay, so this is basically some characteristics, and there are two type of uh, measure of dispersion. So there are two type of measure of dispersion categories of measures of dispersion. First is known as, in terms of it is measured. First is measured in terms of distance between values of selected observations. Values of selected observations. It is also known as distance measure. Okay, distance measure. Example of this measure is range. So range is an example which can be defined as x max minus x mean. And second is basically this is known as average deviation. So this measures this so it basically it averages the deviation of observations from some central values. Okay, say for example mean or median. So it averages, and this is known as average deviation. Simply, this is known as average deviations. Okay, simply mean or median or any point. Okay, so these are two categories of dispersion. Now let us start with and measure of dispersion. So first measure of dispersion and the simplest one is range. And it is difference between two extreme observations. Okay, so what is difference between two extreme observation? And it can be defined as range is equal to x max minus x mean. Okay, range is simplest but a crude measure of dispersion. So it is a crude measure. Okay. And one thing you should note that it is not based on all observations. Okay. Quartile deviation. And it is also known as semi-quartile range. Also known as quartile range. And this can be defined as Q is equal to 1 by 2 Q3. Let us define it by QD, quartile deviation, Q3 minus Q1, and Q3 is third quartile. And you know third quartile, we have already discussed third quartile and first quartile in previous classes, and this is first quartile. And obviously, I think you know it. The second quartile is nothing but a median. So there is no use of second quartile in defining quartile deviation. Now let us come to the third measure, and is known as mean absolute deviation or mean deviation. Okay, you can also and this is mean absolute deviation. Suppose you have a data in form of frequency distribution x1, x2 up to xn, and frequencies are f1, f2, fn. So mean deviation from a average A can be defined as mean deviation from average A can be defined as is equal to 1 by n summation I vary from 1 to n fi modulus of xi minus a. If it is not in form of frequency distribution, suppose it is form of x1, x2 up to xn, there is no frequency or all observation appears only one time, then it can be defined as 1 by, sorry, it should be 1 by n I varying from 1 to n summation of xi minus k. Okay, so it is a different.
Hello, sir.
It is, yes.
S1 के लिए
क्या?
मीन
सॉरी
मीन
सॉरी, ये F2 होगा and it will be Fn. Okay, F1, F2, Fn, frequency distribution. Okay, so this is basically and this represent absolute value or modulus. Absolute value or modulus. So this is basically the mean deviation, and if A is equal to x bar, it is termed as mean deviation about mean. And if A is equal to median, then it is known as mean deviation about median. Okay, so basically it is mean of deviation, and you can if A is mean, then it will be mean deviation about median, and if A is median, then if A is mean, it will be mean deviation about mean, and if A is median, it will be mean deviation about median.
सर मीन डेविएशन अबाउट मीन का मुझे मतलब समझ में नहीं आ रहा है।
मीन डेविएशन अबाउट मीन का मतलब ये है कि ये देखिए, ये टर्म जो है, इस पार्ट को, ये जो पार्ट है, ये पार्ट को कहते हैं हम लोग डेविएशन, ठीक है। और इस डेविएशन का हम लोगों ने एवरेज कर दिया, इसीलिए इसको कहते हैं मीन डेविएशन, ठीक है। इस डेविएशन का जो एवरेज किया, इसीलिए हम लोग कहते हैं मीन डेविएशन। यदि यहाँ पे ये मीन रहेगा, ए की वैल्यू को हम मीन ऑफ एक्स रख देंगे, तो ये हो जाएगा मीन डेविएशन अबाउट मीन, और यदि हम ए की वैल्यू को मीडियन रख देंगे, तो ये हो जाएगा मीन डेविएशन अबाउट मीडियन। दैट इज बेसिकली आई वांट टू से। ओके, कोई डाउट है?
सर ऐसे फार्मूला से नहीं, मतलब अगर जैसे हमारे पास कोई डेटा है, हम उसका मीन निकाल रहे हैं, फिर उसी का मीन से ही डेविएशन निकाल रहे हैं, तो हमको ये समझ में नहीं आ रहा है।
हाँ देखिए, मीन जैसे आपके पास एक डेटा है, सपोज कीजिए कि 3, 4, 5 3 ऑब्जर्वेशन है। मीन आपका क्या हो गया? 4 हो गया, ठीक है। योर एवरेज इज 4। Then deviation, what will be deviation? This x
-1 0 1
-1 0 1, and what is average deviation? -1 plus 0 plus 1, and it will be, and whole divided by 3, because all observation has one frequency, इसीलिए अब ये क्या हो जाएगा? 2 divided by 3. So this is mean deviation about mean. यहाँ कोई और पॉइंट रहता, मीडियन होता, तो फिर हम उसके करस्पॉन्डिंग डेविएशन निकाल के उसका मॉड निकाल के कैलकुलेट करते।
मतलब सर सारे ऑब्जर्वेशन का मीन से डेविएशन निकाल रहे हैं, फिर जो आ रहा है उसका फिर से एवरेज ले रहे हैं।
हाँ, उसका एवरेज ले रहे हैं, ठीक है। ये हम इसलिए कर रहे हैं क्योंकि हम देखना चाहते हैं कि मीन से कितना दूर दूर आपका डेटा है, या ये क्या सारा डेटा मीन के क्लोज है, या मीन से बहुत ज्यादा डिफरेंट है आपका डेटा, ठीक है। यही मेजर
सर जो 2/3 आया है तो इस हिसाब से हम कह सकते हैं क्या कि हमारा जो मीन है, मीन से सारे जो डेटा अदर हैं वो 2/3 डिस्टेंस पर है।
हाँ, एवरेज डिस्टेंस 2/3 है, ये आप कर सकते हैं। सारा ऑब्जर्वेशन 2/3 नहीं है, एवरेज डिस्टेंस जो है 2/3 है, ये आप कर सकते हैं।
सर तो
ठीक है
2/3 मेन डेविएशन अबाउट मीन होगा।
हाँ, 2/3 जो होगा वो मीन डेविएशन अबाउट मीन होगा। यदि मीडियन करना है तो फिर आपको मीडियन रखना पड़ेगा। अगेन मीडियन इज ऑल्सो 4, सो इन दिस केस मीन इज इक्वल टू मीडियन। सो मीन और मीडियन बराबर होगा तो मीन डेविएशन अबाउट मीन और मीन डेविएशन अबाउट मीडियन दोनों ही इक्वल होंगे। ठीक है,
यस सर।
ओके okay, so I'm giving you one more problem. That is 0 to, that is a theorem. Okay, I'm giving you a problem. You have to do it. Prove that the mean deviation about mean x bar. So mean is what? Mean is x bar of the variable x comma the frequency of whose ith xi is fi can be given by 2/n x bar summation fi when xi less than x bar, and this minus fi xi less than x bar. Okay, so you have to do this. Okay, xi less than, in both cases there is xi less than x bar. Okay, so you have to derive this. So basically what you can do is you can define it as, suppose it is 1/n, you know a capital N is summation fi 1/n fi xi absolute value of xi minus x bar, you know this, and it can be written as 1/n xi. If xi is less than x bar, then we can define it as fi x bar minus xi. Am I right? And if for negative value xi less than x bar means xi less than x bar means this will be negative. Okay, xi minus x bar will be negative, and xi and now rest thing you have to do by yourself. I'm writing only one more step. Minus of I varying from sorry, xi less than x bar minus of fi xi minus x bar plus xi greater than x bar fi xi minus x bar. So rest calculation you can do, and what basically you have to do, you have to obtain this result, and you know fi xi minus x bar is equal to 0. One thing you can use this, and this summation of fi xi minus x bar is equal to 0. Okay, so this is a result. Okay, so I'll discuss this in next class, and I will ask this question to you in next class. Okay, so let's start standard deviation. Okay, and I think all of you know standard deviation. And it is also known as root mean square deviation. Okay, sorry, root mean square deviation. It is not as standard deviation. Root mean square deviation is a little bit different, and standard deviation is denoted by sigma. And if xi to xn, x1 to xn, and frequency are f1 to fn, then this can be defined as, sigma can be defined as I varying from 1 to n, 1 by capital N, and fi xi minus x bar whole square, and square root of this, or you can say to the power 1 by 2. Okay, where this is x fi. So it is what? Positive square root of, so it is positive square root of the mean of square of deviations of the given values from their mean. Okay, so one thing I want to discuss that is important if you consider and this root mean square deviation can be written as, this root mean square deviation can be written as 1 by n okay. So this is root mean square deviation. Okay, one thing I want to discuss, you have two type of deviation. One is root mean square deviation and other is mean deviation about A. That is defined as 1 by n.
कैपिटल ए क्या है?
कैपिटल A is any arbitrary point. आप इसमें कुछ भी वैल्यू ले सकते हो, जैसे हमने डिफाइन किया ना कैपिटल A, कुछ इस तरह से डिफाइन किया पहले. ओके, तो ये था, ये क्या है, मीन डेविएशन अबाउट ए. ओके, एंड सिमिलरली दिस इज रूट मीन स्क्वायर डेविएशन अबाउट ए. सो ए की वैल्यू क्या रखें कि ये डेविएशन मिनिमम होगा, या ए की वैल्यू क्या रखें कि ये डेविएशन मिनिमम होगा. तो मैं एक रिजल्ट बताना चाहता हूं जिसको आप डिराइव भी कर सकते हैं बाय कॉन्सेप्ट ऑफ मैक्सिमा मिनिमा, कि ये डेविएशन तब मिनिमम होता है जब ए की वैल्यू आप x बार रख दो, और ये डेविएशन तब मिनिमम होता है जब ए की वैल्यू आप मीडियन रख दो. ओके, तो दिस इज मीन एब्सोल्यूट डेविएशन. So it will be minimum at A is equal to median, and it will be minimum at A is equal to mean. Okay. And you can do your you can prove it, and I'll give it to you as a homework. Okay, prove that mean deviation, root mean square deviation is minimum about mean. Okay, so this was all about today's class. If you have any doubt, you can ask your problem. कोई डाउट है, कुछ छूट गया है किसी का? Okay, so I'll take one more. I will take next class by tomorrow. Okay, so I'll take one more class in this week. That will be an extra class. Okay.
Sir. Yes, sir.
Okay. Okay. So I'm stopping here. And tomorrow I'll announce a class.
Thank you, sir.
Okay.
Thank you, sir.
Thank you.